All right, so finishing the final graphing. Again, I need to make it my t-chart, but first I'm going to look at my transformations. So working my way left to right, that 2 is going to make it stretch, and that 4 is going to make it go right 4. So my vertical wall, which is normally along the y-axis, will be moving right 4, and will be right here. And if you want to go ahead and write that down, that is actually the line x equals 4. And I'll start with this time actually just kind of switching initially my x and y. So realizing when I make my t-chart, I will be using all the stretch and the right numbers out, and I'll be looking at it as an exponent, so 1/2 to the x power, which we made this t-chart right above in number 2. So, but I'm just going to try to make one t-chart and show you again that you can just save time. So again, the x's are now going to be the y's, so -2, -1, 0, 1, and 2. And if I take 1/2 to the x power, again, anything to a 0 power is 1. And then if I keep multiplying by half, I get these numbers. And in the other way, I'm going to, so that's the same as dividing by 2 to go from 1 to a half to a fourth. So I'll multiply by 2 the other way. And now, these are the points for the log function. And I'm going to apply my stretch to the y's. And I'm not going to graph any of the points that have fractions, so I'll leave these out. But I'm going to double this y and make it -4, -2, and 0. And now these are the points I'm going to graph. So as far as decay goes in a log, again, it's flat vertically, but decay still looks like decay like a log, okay? So that's the shape I'm going for. So let me graph these. I'm going to have 4, -4, and I'll still be moving them. So 4, -4, 2, -2, and 1, 0. And now all these points are just going to move right 4, and right 4, and right 4. And I'll graph them flat along the wall, and then they can move out. All right, so as far as my arrows go, the left, the upper arrow, it is going left, but it will be stopped at my wall of 4. And it's going up, so infinity. And the other arrow, it's going to the right, so infinity, but it's also going down, and it's not getting stopped, so negative infinity. So as far as this goes, my domain is from 4 to infinity, and my range is all infinities. We already got the asymptote, and my x-intercept, I can actually see this is a set point. I just didn't quite draw it through there. My x-intercept, where it hits the x-axis, is at 5, 0. All right, so you should try the next set on your own, and I'm going to move into solving and go over these 4. So these are all solving, but these are weird x's. So remember, we got exponent equals exponent, and log equals log, and that's when you can ignore the bases and the exponents, or if it equals a number, you're going to have to turn it into its counterpart. So on the first one, it's an exponent equals an exponent, so I will find a common base, which is 2. So there's 4, and now it's 4 to the 2x power, and the other base will stay the same. I'm going to put a 1 in front of that x. And now that the bases are the same, I can ignore them and focus on the exponents. So the left side is 4x. Here's -1x minus 0.5. I'm going to get the x's on the same side, so I'm going to add an x. And I get 5x equals -0.5. And now to get x by itself, I'm going to divide by 5. So in my calculator, I'm typing -0.5 divided by 5. And x is -0.1. Number 2, now this is exponent equals a number, so I will be turning it into a log, but I can't do that until it's just the base and the exponent. So first I'm going to move the 5 over, and you can leave it as a fraction, you could write it as a decimal, I'll just put it as the decimal, and now I'm going to do the log. So it's going to be log 18, and then the 5.2 equals 16x. So again, some of you can just press the math button and scroll up. I will point out on this time what the rest of us have to do with those TI-83 calculators. But this is a number, so some of you will have to type this in. And when you do that, you'll get about 0.570, and that equals 16x. And now to get x by itself, I'll just divide by 16, and my answer is 0.036 rounded. All right, next one is a log equaling a number. So when a log equals a number, I will be turning it into an exponent, but I can't until this is 1 log. So ignoring the log for now, but I'm writing it here, it does have a base of 10. That subtraction is going to be turning to division, so it's going to be 3 over x. But now I'm ready to do my exponents, so it's going to be 10 to the second power equals all of that. Well, 10 to the second power is just 100. And now to solve for x, I don't want it in a denominator, so I'm just going to multiply by x on both sides. So I get 100x equals 3. And now divide by 100, and your answer is 3 over 100. Number 4 is similar because it's a log equals a number, so I will condense it down into 1 log equaling 2. And when you ignore the logs here, this plus will turn into multiplication. So here goes my exponent. 4 to the second power equals that. I'm going to clean this up. This becomes 16. The right side is x squared minus 6x. And now, since there's more than one type of x, I'll bring everything over to the right side so it can be easy factoring. And now I just need factors of negative 16 that get me to negative 6, and that is a negative 8 and 2. And so my factors are x minus 8, x plus 2, and what makes these 0 are 8 and negative 2. And those are my answers. What it does not say here is extraneous solutions. And logs is one of those times you have to worry about extraneous solutions. You cannot take the log of a negative number. So just as a reminder why. I can't take the log of negative 8. It doesn't matter what the space is, because I can't take 2 to a power and ever get negative 8. Okay? I can get 8, I can get 1 over 8, but I'll never get a negative number. So in your log problems, you do need to make sure that your answer, when you put it back in, does not have you take the log of a negative number. So when I put it back into 3, I'm taking the log of 3/100ths, that's fine. And when I put 8 back in here, I'll be taking the log of 8, and over here I'll be taking the log of 2, that's fine. But when I put negative 2 back in, I'll be taking the log of negative 2 here and the log of negative 8 here. So this one is not technically a solution, it's an extraneous solution. And in the multiple choice part, you will see 8 and negative 2 listed as an option for an answer, but it is not the answer. The only answer is the one that has 8 in its choice. Okay, you'll try those on your own. And I will be working on these videos. I don't know how far I'm going to get, but at this point the bell's going to ring and I've got to get this loaded up. So we'll see how that goes. All right? So check back under the Algebra 2 folder if you don't get to this point.